Hello, and welcome to the Summer Series Programming Workshop. This one is called Steps for Intermediate Learners. I chose this title because I see a lot of content out there for beginner, like first robotics teams, like the real basics, and a lot of stuff on like Chief Delphi for like advanced kind of concepts, but the in-between's a little lacking. I know there's a lot of teams out there that started but don't really know where to go. So I'm Bryce. I was the lead programmer for Team 5199 in 2019. And then I'm presenting with Ashwin.
Hi, sorry, I'm Ashwin. I'm the lead programmer for 3476. I was the lead programmer in 2019 also.
So for the sake of this presentation that we're doing, the kind of assumptions that we're making, because we want to skip over some of the beginner stuff, is you know how to use like the driver station, and you can handle like getting to know a programming language on your own. Basically like all the provided software and like minimum expectations, like you have that down. And I know a lot of teams will find themselves with just one programmer, and that's all fine. But it's definitely a lot better of an outcome if you have more people working on the programming section, even if those people can be hard to come by. So I would say encourage everyone on your team to at least give programming a shot, even if they don't think they're capable of it. And they might surprise themselves. There's a lot of resources online to like get people started and get them going. And the other thing is when you have a team of programmers, like the big thing for doing teamwork in programming is you have to be organized, because otherwise you're not going to get anything done. Like all the work, any work you do will just get lost in files that are misnamed and stuff like that. And then in terms of development environment, just use VS Code would be my recommendation, the one that's provided to you by FRC, because it makes that organization step I talked about before pretty easy. I'd also recommend, if you're interested in this kind of presentation, checking out the Read the Docs page for FRC Programming Done Right, which I think is a really good resource, and An Idiot's Complete Guide to FRC, which covers more than programming, but has some good programming stuff in there. So starting the actual presentation, I guess, with what language you should use. There's actually a lot of options out there right now for programming languages, with the newest inclusion being Python, which I believe was officially supported starting in 2019 or maybe 2020, but it's there now, and it's pretty much just as supported as the other languages, so Java, Python, C++, LabVIEW, and each has its own benefits and drawbacks, but just use whichever one you think you'd be most comfortable with. They can all do the same thing at the end of the day, and I have some links for where you can get started with those languages for FRC if you so choose. What are those benefits and drawbacks? C++ is probably the fastest because it gives you a lot of access to low-level things, which means you can use memory more efficiently, and so it runs faster, sometimes marginally. Java is a lot more user-friendly, in my opinion, than C++, and still offers a little bit of that low-level access, but at the cost of it being a little slower. And then Python is not really a low-level language like at all, and it's sometimes pretty slow, but it's super easy to use, especially if you're just getting into programming, because the syntax is so like dumbed down and the whole white space thing. So one of the big parts of programming, in my opinion, in FRC, from my experience in season, was part of a programmer's job is just to sit in at the beginning, and when build season starts, they give you your challenge. When your mechanical design team's coming up with mechanical designs, you have to be able to let them know when they're making something that's going to be ridiculous to like actually make it work in software. That's a mistake that is made sometimes by rookie teams. I have a picture of a kind of a crazy example in the top right. They got triple jointed arm on a turret, etc. And that's because like programming for robotics in general, like just the field, comes down to the physics in whatever mechanical like mechanisms you want to use. You have to be able to break down the physics, how they work, and then get the sensors ready and the computer ready to control that mechanism. So if that mechanism is like super complex, it's super complex to program.
Yeah, don't build crazy elevators on turrets is what he's trying to say. Yeah, so one of the things that's difficult sometimes is figuring out how do we prototype and iterate on our code, because before the season starts, you can start writing some code, and then as the season goes on, your program evolves. So that's what we want to talk about here. You should start with pseudocode. And pseudocode is not necessarily just comments. It can be function prototypes. It can be empty classes. It can be kind of the structure for what you think your program should look like as the season progresses. And then for a lot of things, it makes sense to basically draw out diagrams for what your code should do. And I put an example here. This is actually a diagram of how we were going to basically correct our turret's aim using vision. And you can see this is a reasonably complicated model, and it's often just very difficult to start programming in this math without having seen it drawn out and understanding what it's going to look like in the real world. So that's something you should do. And also you should be strategizing with your team. You should be talking through with your mechanical and your CAD people and figuring out what mechanisms are going to look like and what kind of stuff you're going to have, what points of control you're going to have and sensors you're going to have, because that's going to help you a lot. The other advice that we have for you is you really should be using those object-oriented features of C++ and Java. Those are very powerful features for being able to iterate, and you should be using them. And to that effect, you should be basically taking subsystems on your robot and really representing them as subsystems, as independent subsystems in your code. You should break those things up into classes, and you should implement the functionality that you think you might need as functions within those classes. And as you go on, you'll see that if you do that, it's really easy to start substituting methods and substituting things into those classes as you iterate. And we put an example down here. This is like a flywheel class. And let's say early on in the season, you write this prototype control method, right? And as you're doing that, if you're programming with good practice, for example, the thing that gets the RPM of the flywheel will be a separate function. And then later on in the season, when you go to write a more advanced control method, you already have all the building blocks that you need to do that because you wrote them for the prototype control method. And even more than that, when it comes to actually changing between those two methods or even switching between them, if you want to do that routinely, it's really easy because, again, everything is in your flywheel class, and maybe your flywheel class has this update method, and you just simply switch out which function you're calling.
Yeah, I would also say like it's difficult to break up a mechanism like into subsystems. Like it's difficult to break it up too much. Like you might think you're going too far, but you really can't.
Right.
Okay, so on to the toolkits that are provided by manufacturers and the APIs and libraries that are provided to you to make the robot work. This is something that sort of goes along with like basics. Like to get the thing working, if you have Talon SRXs on your robot, like you have to use the toolkit to install certain things. And you might already know how to do that. But the other thing that is worth noting is with those devices, there comes in the API a lot of built-in functions for you that maybe have been overlooked before by some people. There's a CTRE toolkit, and there's an API that goes with that for your Talons, the new Falcon 500, and even just for sim motors. And you can feed data into from an encoder or something into that controller, and it'll automatically do things like motion profiling or like velocity control and things like that. It'll do that for you. Definitely get familiar if you're just getting into programming in FRC with the library that's provided to you by the first partner university, WPI, Worcester Polytechnic. There's all the different like basic functions you might need in there, so you don't have to necessarily do those yourself, or maybe example code that you might need to get going. That's all in there. And also look at the different robot bases that are available and think about which one might work best for your robot. Some of the hardware even will, like I said, require you to have certain toolkits to install like the CAN bus, like device ID manager on the Rio. Like you have to do that for CTRE devices and stuff like that. Here's a picture of the Phoenix tuner where you do that device ID handling, and you update firmware and things like that. And that's just something you need to get things working. It's pretty easy to use. It's like pretty intuitive, and they have all the information you need to get it working in the documentation for it, which I have linked in this PowerPoint. And then here's a picture of the API, the library basically of functions and enumerated types that comes with the Spark Max motor controller. And you can see that there is, you can read from the Neo motors that come with an encoder, and they have a function already to read the encoder output. So that's maybe, if that encoder suits your needs, that's a step you can skip. There's things like that you can do pretty easily because it's already there. And now we're moving on to the next section, which is about how you give your robot a view of the field and like the outside world, I guess, with sensors. So sensors and single board computers are, all the different things at your disposal for giving the robot some kind of eyes and ears. So the rangefinder that comes in the kit of parts, any cameras, color sensors, gyros, encoders, and all of that gives you data about where your robot is, what it's doing. And then single board computers like a Raspberry Pi, or maybe something faster like an NVIDIA Jetson, can give your Rio, because it's not the fastest computer in the world, access to more ports for more sensors and more computing power for doing more complex things. So here's some common single board computers. There's a lot of vision tracking that happens in FRC now. And this is something we're kind of going to gloss over in this presentation because there's already so much out there. But these are good examples of ways single board computers that interface with the Rio come in handy. So the Limelight, which you can buy and just plug into your Rio, and it'll get vision tracking working, or you can get your own Pi camera and your own Raspberry Pi and use Chameleon Vision to get the same thing done, vision tracking. And it's not as difficult to set up as you might think, I guess, I would say. And there's markers all over the field that make it relatively intuitive. The data that you need from these devices, you can pick up over the network on your robot, which is like the Ethernet cables that run around. And it's done with network tables for these two particular devices. There's also, of course, encoders. And encoders are a fairly simple thing. It just counts how many times a shaft has rotated. So there's a couple ways that encoders will do that. There's Hall effect or optical encoders, are probably the two most common. And it allows you to do two main things, which is move a mechanism, so let's say an arm, to a specific position, because you know where the shafts of the motors have rotated, so you can see where the arm is going, and you can also see the rate of rotation of the motor. This is oftentimes, actions like these are handled with the PID controller internally in the motor controller, which, like I explained before with the API, you get access to through that API, and it's fairly simple. And we can also use this data in programming when making our own autonomous code, so just driving along paths, or maybe controlling an arm using the encoder data, like I said. And then there's IMUs and gyros. They tend to mean the same thing. An IMU is just a sensor that can give you, with varying degrees of accuracy, the orientation of your robot in any of the three like cardinal directions, or any of the four cardinal directions, excuse me. It's like north, east, southwest, or its angular velocity again can be measured with this, and like where it's facing at the moment can be useful for the case of autonomous driving, because you can check if you're facing in the right direction before you do anything. There's this thing that happens called drift with the gyroscopes in these devices, and that's something you will have to learn to account for as well. But the sensors that are offered in an IMU package, like the Navex MXP, for example, is a common one. It interfaces with the RoboRio pretty easily. Comes really in handy for doing all kinds of things with the robot, including autonomous driving with an operator, like a driver, or many other things. And I also wanted to talk about human interface devices. This was something that came up for my team big in the 2019 season. It's really easy now to get an Arduino code-based device like a Teensy LC, which I have pictured in the bottom, and just hook up a bunch of arcade buttons off of Amazon to it and stick them in a panel and give them labels. And all of a sudden you have direct inputs from the operator or driver saying that they want to do something, instead of having some kind of like shortcut workaround for press the left trigger and the A button at the same time to do this. You have more buttons available to you that make it more intuitive to operate the robot. And this can help a lot actually playing the game. And it's not a particularly difficult thing to learn to program if you already know object-oriented programming, because Arduino is extremely accessible. So I think that this is something that a lot of teams should consider adding to their repertoire of like things you can program to make the robot better. And another thing to consider is providing the driver and the operator with some kind of visual feedback when an action is taken, whether that be like a light or a number changing on the smart dashboard, which is something you can control in code, of course, or having a camera somewhere on the robot that gives you vision of whatever side of the robot, and having that displayed on the computer at the drive station. Ashwin told me about a team with an interesting workaround for elevator positioning, where they had a camera positioned facing a measuring tape that was strapped to the elevator, and instead of actually using an encoder to read its height, they just looked at the measuring tape through the camera, which, you know, that's something you can do, I guess. So now moving on to controlling your robot well.
Yeah. So, you know, control is one of those things that both in autonomous and on top of your driver control as an augmented thing in driver control can really take your game kind of to that next level and really give you a competitive edge. And it's something that a lot of teams don't do, but really could implement fairly easily. So we want to talk about that a bit. The two simplest types of controllers that are commonly used in FRC are the bang bang and proportional controller. So starting with the bang bang, it's a two-step or on-off controller, and you'll commonly see it called hysteresis. And it's a feedback controller that basically switches between an on and an off state. It's exactly what it sounds like. It goes bang, bang. So the advantage is it's really easy to implement because there's no gains or no constants to tune, and it's very, very effective for certain simple systems. And on average, you'll see that if you use a bang bang controller over long periods, the average state of the system is going to be your desired set point. But the disadvantage is that you will see oscillation around the set point, and on certain mechanisms like elevators and arms, it's going to lead to very jerky kind of movement. We would probably recommend using it in something like a flywheel, where you will not really see that oscillation and it won't lead to jerky movement. And this graph here on the right kind of shows you what this controller does, but the idea is that beyond a certain set point, you don't apply any control, you don't apply any signal. So what this is showing is like controlling temperature with a heater and a bang bang controller, and you can see that when the temperature is below the set point, the heater is on, and then as soon as it passes that threshold, you turn off the heater, which is great, and then the temperature starts dropping, and then it turns back on again. And on average, the temperature is going to stay at that set point, but you can see that it oscillates. And for something like temperature or flywheel RPM, this might not be a problem, and it's a great controller. Now, if that doesn't work for you, proportional control is also pretty simple. And instead of just turning on and off, it actually applies input which is proportional to the error measured by the sensor. An error is usually defined as the set point minus the actual value of the sensor. And what this does, the behavior you'll see, is it enables basically a throttle down in sense as you approach your set point. So the advantage is it's very effective, and it's a lot more smooth than Bang Bang. And it can even account for certain kinds of noise, like being bumped by another robot in the field, or more friction than you might expect, or something like that. It can be tricky to tune the constant. There's a constant that's involved. It's basically the proportionality constant. It's how much signal to apply proportional to your error. And it's subject to undershooting because of what's called steady state error, which we will talk about a little later. But it is appropriate in a lot more applications. You will see this used in drivetrains, in flywheels and elevators and all kinds of things. And this graph here basically shows a proportional controller with three different constants for the proportional controller. And that blue line is the set point. And you can see that the system with a high proportionality constant basically gets up there to the set point, but then overshoots and then oscillates around it. And with a low constant, it doesn't quite get to the set point, but it almost makes it there, and it kind of throttles down smoothly. But there is some steady state error, which we'll talk about. And here's the code for those, and you know, you notice that these are really simple. These are both 2 lines. And it really is this easy. You might have to limit the output range or whatever, but otherwise you should be able to just kind of plop these in there. The only thing that might be tricky is tuning KP, and that's just going to take some trial and error. There are certain methods to doing it, which we're not going to cover here, but you can look those up if trial and error is not working for you. So sometimes the proportional controller alone is not sufficient, and it does have some problems, which we talked about. We talked about how it can overshoot. There can be oscillation. There can be steady state error. And because of that, it basically leads to this PID controller, which stands for proportional integral derivative. And these are kind of fancy terms, but in truth, they're very simple ideas, and we're going to just break it down and talk about those ideas. So derivative is basically the calculus term for instantaneous rate of change. But because our controller is running so fast, the average rate of change between iterations of the loop is a pretty good approximation. And basically what we do is we can limit the oscillation of a proportional controller by scaling the output signal by the rate of change of the error. And that's, again, given by error minus previous error divided by delta time, which is the average rate of change of the error. But because we're running so fast, it serves as a good approximation of the instantaneous rate of change. And then, again, we're going to multiply that by a gain constant for the derivative term. And if you start thinking about what that actually does, you'll basically, you can imagine situations where if the error is decreasing very quickly, the signal will be dampened. And the opposite way around is true too. If the error is not closing in quickly, then the signal will be larger. So I keep talking about steady state error, and I should probably explain that. Steady state error is the idea that there are some errors that act continuously on a system. That's things like gravity and friction. And the idea is we just want to get rid of those. We don't want to have our proportional controller deal with that kind of thing. And it's also the case in systems with high inertia, like flywheels. So what we do is we use this integral controller as part of our PID. And the integral is this idea of the area under a curve. And basically, again, since we're iterating so fast, the area under our error curve against time, it can be approximated pretty well by rectangles. And what we do is we use the integral term scaled by a constant to prevent steady state error. As far as tuning goes, what we recommend is basically raising the P gain until you're oscillating around the target, raising the D gain until you've dampened the oscillation, and then adding an I until you've eliminated your steady state error. So this is some code for basically a full PID controller. And again, it's very short and it's reasonably simple. You can see what we're doing is we're getting the delta time. We call this controller continuously, right? And we're basically, the accum variable is the integral term I'm talking about. At every iteration, we're adding in the error times the delta time. And then the output signal is really just going to be the Kp times the error, just like the P controller. And then Ki, which is the integral constant, times the accumulated error. And then Kd times the rate of change of the error, which is the error minus the previous error times the delta time. And then that's really all there is to it. And what you'll find is that this controller is really, really effective for a lot of things, and it gets used very often in FRC. And like we mentioned earlier, this controller is so common that it's built into things like the Talon SRX and the Spark Max. So you should be able to get this going pretty easily.
Yeah.
So a lot of newer teams also find themselves struggling with how do we do the autonomous period? How do we basically move the robot without a driver? And it seems like an extremely difficult thing, but in truth, it's not that complicated once you understand these controllers that we were just talking about. I will note, driving 2D pads is kind of a complicated subject, and really you can go infinitely in depth into that, and you can look at controllers like Pure Pursuit or try trajectory falling, but I would recommend first getting like a one-dimensional case working, the kind of thing where I can tell my robot, move 20 inches forward, and it moves 20 inches forward. So at a minimum, what you really should try to do in autonomous is have functions that make it really easy to drive pads made of discrete linear segments and turning in place. So I've kind of given just a little bit of structure for what that code might look like here. You can have like a move function where you put in a parameter in inches, and then it basically converts that to encoder ticks, and then does a PID or a P controller on that encoder, and then it moves you to that location. And then in your autonomous, you can imagine chaining together these move calls to do things, and it's going to look a lot cleaner than just using time. And even if you have to use timing, like delays, like starting motors and then delaying and then stopping motors, you can still use functions. You can basically determine a constant, like inches per second, and in your move function, you can use that constant and make things cleaner. And you can do the exact same thing for turning. Instead of PIDing on encoders, you can use your gyroscope, or you can use time again. And then on the right, what I included here was like actually having sort of a pathing library, because once you have those functions, it's pretty easy to write something where you can just put in points on the field that represent actual field coordinates, and then drive to those points, again, with those discrete linear segments and turning in place. So like what this one does is it basically iterates over all your points, and it computes, if you can imagine, if we're on some arbitrary point on this path up here, it computes basically the vector from the previous point, and then it tells you how much to turn, and then you turn that amount, and then you move. And actually, there's an error here. It should be the next point minus the current point, but it's the same idea. So this is like an example of a more complicated controller. This is for driving 2D pads. It's a Pure Pursuit controller, and it's kind of beyond the scope to talk about, beyond the scope of our presentation to talk about how to actually implement this. But the basic idea is that There's a look ahead radius, which you can see illustrated by the circle. And you can take those pads that you made, and instead of just driving those lines and turning at the endpoints, you can basically track the path, and you can follow an arc, a smooth arc, to drag the path. Another thing you might see mentioned a lot is motion profiling. And this is just the idea that we can use PID to execute smooth motion and control the velocity of our system. Instead of using PID for position, like we talked about previously, we're going to use velocity, and we're going to use our knowledge of 2D kinematics. And if we do that, we can not only control our velocity, but we can also make sure we end up in the right position afterward. The basic idea is you can write a function where you specify the max velocity, the max acceleration, and the desired position. And then, as a function of time, I can compute a target velocity at any given point. And you can kind of go through and derive this yourself. There's also lots of code out there, and I provided one example here too. But if you kind of go to your basic kinematics from physics, it should be pretty easy to follow like a trapezoid motion profile. One of the things that we really recommend you do is use version control. Version control, we recommend Git. It basically is software that lets you keep track of all your changes to your code, and also makes it really easy for lots of programmers to develop the same code, basically different parts of the same program, and then on what are called branches, and then they can merge them together to make one final program. GitHub is commonly used too. Don't get it confused with Git. It's actually a different thing. It's a place where you store Git projects, and these projects are called repositories. And it does have some very useful programming features like issue tracking, which should make it really easy to collaborate. Different versions of the same files are stored as commits, which basically contain the changes to your tracked files. And to actually use Git, again, there's a lot of literature out there, but you can access it through your command line, and it's a really good thing to do it that way, but also there is a desktop client, which makes it a little easier to use.
Yeah, one of the things that you and I have both seen some of the more rookie teams like lacking in terms of collaborating with code is using Git. I've seen teams at competitions who, instead of having like a GitHub profile where they keep all their Git projects, they have like a thumb drive or like a laptop that has everything on it. And I've seen teams lose all of their code at a competition. Like it's gone. Whether the guy's not there, they don't have the flash drive, the robot breaks down, they have to change it, it's gone. And I've had to I remember one competition, I had to rewrite all of the basic code for an entire robot in like 5 minutes. And all we really get it to do was like drive. Like there was no point in even trying really. And so version control is really important just to have backups if nothing else, but also for collaborating for sure.
Yeah, it's a very powerful kind of feature too, because it lets you do stuff like as you're writing code, if you realize that you overwrote something or you made a mistake, you can just go back. You can go back to any version at any point in time. So it's very useful. For
sure. Another part of sharing code with other people and your teammates is making sure you can all understand in your, the GitHub folder you create, so the project you're creating, you gotta all kind of understand the logic behind what you name folders, how like mechanisms are broken down, class names and variable names, so that it doesn't, for one, just so it like is more organized, like it looks neater, but also just so things don't get lost. A good example is, of course, separating your robot by mechanism, like we talked before about. You can't really split up the robot too much, but definitely discuss with the people who are collaborating with you, the mechanism that controls driving is just the drive train. Like it's not this other folder that is also called drive. That they should either be together. You should all understand how it works. And then a common practice is using a standard like camel case for casing for naming variables, so that when you're just trying to type out code and you're trying to call a variable from a class someone else created, and you type it out. Because it's not in camel case, you're like, what is it called? I have no idea. And you have to go look. It takes up time. It's kind of annoying.
Please don't name your variables things like good and bad. We did have that in our code. It was very confusing.
Having good file and variable like naming conventions and practicing them, like don't just come up with these and then not do them, like practice them, practice using them. That'll help you get organized a lot, and it makes not only like your job easier, but it makes the people who come after you and want to look at the previous season's code, it makes their job easier too. And another thing is comments. I'm guilty, like everyone else who has ever programmed anything, of making code with no comments in it. And it's not a good practice. Like, I'm not proud of that, really. You should always comment your code, especially for these group kind of projects, so that other people can understand it. And also just to make your job easier, again, so that you can debug it more easily. Like, you might write a piece of code a week ago, you come back to it, how does this work kind of thing? You have to sort of go through the whole thing again. Comments really help.
Yeah, and then the last thing we kind of want to cover is just how do you maintain your old code and code that you're going to keep using? Because this is something you should be doing. I mean, you absolutely should do this, because you're going to find that as you go through more seasons, you solved problems that you're going to encounter in future seasons. And it will help you both avoid wasting time writing the same thing and also repeating your past mistakes. So again, that's where GitHub comes in. You really should be using version control in Git, and you should be backing that stuff up. And if you've been making good use of object-oriented programming the whole time, what you'll find is that it's really easy to recycle old classes and methods. I mean, to the point where I can tell you on Code Orange what we do is we have certain classes. We have things like our Pure Pursuit controller, or we have a class called Orange Utility, and we build those things out season by season. And every year we literally drag and drop those Java files into our new program, just exactly how they were. So you should be writing your code with that kind of reusability in mind. And the example that I gave here, which I think is a very common example, is if you find yourself finding the magnitude of a vector over and over again, you should have a get magnitude function. And you can put that anywhere you need to find the magnitude of a function, and you can put that in your utils class as a global function or a static function. But even better design would be to actually write a vector class, and it has properties like x and y and get magnitude and add and cross and dot, and whatever you need in your vector class. And you'll find that as you solve more problems, you'll start building out this class, and eventually you'll get to the point where when you solve a similar problem, you have all the infrastructure you need to solve it.
I've even found between like myself and alumni, like if we build out classes that we reuse a lot, and unrelated projects to FRC, you can go grab that class or piece of code or call back to that knowledge and use it somewhere else, like completely. And that's really the power of object-oriented programming. And so definitely take advantage of it.
Right.
So that's the end of our presentation. Those are links above to the GitHub repositories of our teams. And if there's any questions, we'll take them now. Do you have the YouTube page open?
I do. I have it open. I don't see anything, but we can wait a bit, see if anyone has any questions.
Thank you.
Okay, so Rick is asking, how do you typically get new members to join programming? Okay, so let's see. You might have an answer to that too. What I will say on that is that is difficult, especially because programming is one of those things where you do need to know like the basic stuff, like the syntax of the language, conditionals and control statements and stuff before you can start working on robot code. But what we do on Code Orange is, one is we have off-season training. We have people who know programming, who are basically holding workshops and teaching other people on the team, and just getting them comfortable with basic stuff. And that way, when the season starts, they can start programming.
Yeah, I would definitely say the same thing. Like it doesn't take that long to pick up enough knowledge to like start programming a robot, but like the sooner the better. So if you're trying to recruit more people, either like this goes with recruiting new members, like go out of your way to find younger people in, let's say, your high school and get them going with just making like a simple robot with a Raspberry Pi and like Python or something, or just learning code like on the computer, like Java code, whatever your team standard is. Like just get people using it, and they'll find if they're really into it, like they're hungry to tackle more complex problems. And if you're talking about more like getting people to learn it, that's its own sort of topic, and there's tons of information online if that's something that you're lacking in, for like getting started with that stuff.
Yeah. Paul is asking, was the derivative term supposed to say divided by in your PID sample code? Yes, that was an error. I just saw that. Thanks for pointing that out. So on slide 22, where we give the PID sample code, we show KD times or minus previous error multiplied by DT, but it really should be divided by DT because, again, we're finding the rate of change there. So yeah, thanks for pointing that out.
Yeah. Tina asks, what is the best way to learn a new language? In this case, Python. So I can comment on this because Python is like, at this point, it's one of the only languages that I use to do like a lot of things. It's really powerful. I love Python. It's easy to pick up if you really just get started. Like the advantage of Python is, it's kind of slow, but the advantage is you can just like make code easily on your desktop. So like a good resource, I would say, if you're looking for a book or some kind of website, is there's pythonprogramming.net for Python, and there's a book called Automating the Boring Stuff with Python, and that's like how to do PC automation kind of stuff. So like, just little scripts to like do things automatically on your computer, and that's sort of how I started.
Yeah, I will say books are really, really good, and they're often very underrated. The cool thing about books is that if you go to the library and you pick up a book, it had to get published, which means that there is a standard that book had to meet for it to get published, which is not true of everything that you find on the internet or on YouTube. So yeah, I would really recommend books. They're often very good.
So Tina, I would definitely, if you're into Python, just start doing something, get a book, and just use all the online resources available to you, especially if you're talking about FRC. It's now an officially supported language, so it'd be a great step for doing FRC programming.
Paul is asking if we wanted to start using Python programming on robots, is there a less expensive option than the RoboRio? Yeah, there absolutely is. The tricky thing, so the RoboRio has WPI lib, which has a lot of nice functions in it for robot programming. You might not be able to use that if you don't use a RoboRio, but there are other microcontrollers out there and microprocessors that work really well. I think I would definitely recommend looking into like the Raspberry Pi. That's a very common one for really simple things where you don't need like a full Linux operating system. You can use an Arduino. You can also look into the NVIDIA Jetson Nano, which is a much more powerful microcontroller, but it's basically able to do a lot of cool things with artificial intelligence and with image processing. So it's a good controller.
I'd say the cool thing as well with any of those is like articulating that to FRC later. Right. You can reuse those microcontrollers in like the FRC like games for all kinds of things. So it's good to get your start there for sure. Yeah,
for context, we use a Jetson TX1 as a coprocessor. for our vision. And we basically communicated with the RoboRio using UDP networking. So you can definitely use that stuff later on.
Yeah.
All right. Any other questions?
Well, thank you, everybody. We are out of time for this workshop. If you have any other questions, I'm sure our presenters would be happy to answer them in the YouTube chat, so you can post them and they should be able to respond. We'll be back in about 5 minutes with our Chairman's Award panel, and we hope to see you then. We'll be fading to black, and we will be back as soon as possible. Thank you for watching.
Thank you. Hi, everyone. Welcome back to the 2020 Summer Series. I'm Morgan Malloy from 5199, the Robot Dolphins from Outer Space. I'm your moderator for today. Today, we'll be discussing Chairman's Award and the different ways team approaches it. We are welcomed by panelists from 3309, the Firebots, 1622 Spider, and 2485, the Warlords. They can introduce themselves now.
I'll go ahead and start. Hi, I'm Adrian Machado from Team 3309. I'm the Vice President of Business on that team. I'm joined by Mr. Badzi, who's our business mentor. He really helps me with writing the essay and staying on schedule. And I'm joined by Cruz, who has been a presenter for 2 years and has worked on the essay and executive questions.
Hello, my name is Madeline Nguyen. I'm the VP of Robot / Chief Project Officer and one of this year's Dean's List winner. I'm from 1622 Team Spider, and we're joined by our team president, Jenna Cal.
Hello, I'm Luca Bonanno. I am the Business and Outreach Department Head for Team 2485, the Warlords, and Chisato is joining me here today, and she is our Director of Award Submissions.
Cool, thank you so much. So we're going to start with some pre-done questions. How do you guys organize your chairman's sub-team?
All right, I'll go ahead and take that. So our team, in terms of chairman's organization, we mainly designate, as I mentioned earlier, we have an awards director, which is Chisato this year, and our awards director is in charge of putting together basically our presenters and assigning people, members of our team, to work on essay supplementals and executive summaries and whatnot. And they basically, anyone who is interested in being a presenter is able to join the department, I guess, temporarily. You don't have, on our team, at least, you don't have to be a member of the business department to be a chairman's presenter. And then otherwise, in terms of organization, it's pretty much that simple, just assigning tasks throughout the year to ensure that you put together best submission possible.
Does anyone else have something to add?
I guess I can take this question for our team. So we recently updated how we do our leadership, and basically how the, I guess, business / chairman's sub-team is organized is it goes president, VP of business, and then underneath the VP of business, you have our chairman's lead, and then many of our administrative roles like secretary and treasurer also fall under business, and together they all work together as for award submissions and the chairman's essay and stuff like that. And we basically run under chain of command. If something goes wrong, you talk to the chairman's lead, then the VP of business, then president, and then mentors from there.
Yeah,
And then
go ahead. No, go ahead, Adrian.
Okay, I'll take it, Mr. Badzi. As far as how 3309 organizes kind of how they complete the award submission for chairmans, we have the vice president of business and the kind of business department. We work on fundraising, award submissions, kind of everything that could fall under business. And then we also have the vice president of marketing, whom with which we kind of work on for graphics, visuals, the chairman's video. We give them the freedom to kind of take our message and transform it however they want to.
And we have a question from the chat. Keep the questions going, guys. How do you pick the chairman's team and the presenter?
Our team actually, like Adrian was saying, we have the business team, the marketing team, or pretty much that's their charter to work on the presentation and the essay. And presenters are usually selected by tryouts. The business team usually has first right of attempt, but if anyone else from the rest of the team wants to try out, they're welcome to do it. And then we have basically a tryout session where they get to do a reading of the previous one to see about their presentation style.
For our team specifically, we choose our presenters through, similar to what Mr. Badzi mentioned there, an audition or tryout process. If there's enough interest, sometimes we don't have as many people interested to go through a full tryout, but we've actually had a lot of success bringing in presenters from outside the business department. So it's not business exclusive one of our presenters last year was actually from design, and in the past we've had people join from software and all the other departments. So I think presenters are definitely something that you should focus almost like a team-wide search for, as opposed to just sticking within your department, because you can really be missing out on some very effective presenters by not really opening the lens of, or opening your scope of who you're looking for.
For us, we basically open up the opportunity to anyone who's interested on the team and really try to nominate or like try to, I guess, get the younger members involved so they get somewhat some chairman experience a little bit earlier on the team. So in future years, if they want to pursue chairmans, they're more than willing and they have some experience. But yeah, for the most part, the opportunity is open to anyone, and we make sure we train and, I guess, help whoever is interested practice for the chairman's presentation.
And we have another question in the chat from Rick Jung. Can the teams mention their successful records with receiving chairman awards?
I think we've received it 5 years straight, I think.
6.
I'll check the blue. 6?
That's 6, yeah.
I'll check the blue lines, but we're up there.
Our team won the Chairman's Award in 2017, 18, and 2019. So 3 years in a row, but not this most recent year.
Well, we won it this last year for 2020, 2019. I don't think we won it in 2018, and then 2017, and then I also think 2016.
Okay, so the next question is, how early do you guys begin writing essays for chairman submissions? Does one person or multiple people write the essay? And let's start with Team Spider.
Sorry, I was trying to. We began writing our essay basically as soon as we go back to school, and we format it and we try to get rough drafts done before Thanksgiving or when we have our winter breaks, and then we still work on it until a few days before submission, because we're constantly adding information because we don't stop and we do outreach throughout the entire year, even during the summer. So mainly we focus on collecting that data at first, putting a little bit of a base, and then we polish it towards the end of the submission date.
So for our team, from the summer to the first few months of the school year, we try to focus on recruiting and training new members. So I would say that we start thinking of what chairman's theme that we want to have, and then subsequently the essay writing probably late October into November, right before Thanksgiving break. Try to have some sort of draft done before kickoff, and then after that, along with the rest of the presentation, just keep on drafting, writing, and then doing all the organizational things until submission.
We have a theme every year that we decide on, and we kind of are inspired by the theme. We don't really just like sit down and pick one. So we'll typically work on the chairman's essay starting in October. That's when we'll start gathering kind of the outreach that we can use, start thinking of possible theme ideas, and then once we nail one down, which is typically before Christmas break, we'll get to work writing the essay, coming up with multiple drafts, and then working on it up until the end date, because as Spider said, we never really stop doing outreach, so there's always constantly things to update it with. As far as whether it's more efficient to have multiple people writing on it, multiple people writing the essay, as to one person writing the essay, I think it depends on choice and style. There are a bunch of different ways that it can be done, that it's been done successfully. There's only just pros and cons. If you have one person write it, it's a lot more work for that one person, but it provides a continuous voice in the writing. However, if you use multiple people, that can provide multiple different perspectives. So Team 3309 typically writes it with one or two students working on it with the help of some mentors. And that's how we go through our chairman's writing process.
And we have another good question from the chat. How do you guys plan on maintaining outreach with everything going on with COVID-19?
I guess we could go first. It's been a big change, not being able to meet in person, but we're really trying to focus on the virtual aspect of things. During these last 7 weeks, we've done actually a virtual STEM career series, and we plan on doing a ton of more virtual events, especially to reach out to the teams that are mentored globally who didn't have the chance to compete.
Our team, the Warlords, are actually making our first, I guess, virtual appearance soon. Well, I guess this is our first virtual appearance right now, but our first team-led outreach event online will be with the Spice Gears in Poland, and we're making some videos and appearances at their summer camp that they're running. And I guess we're maybe a little bit behind the curve in terms of online outreach events as we're swinging back into the summer and fall with training new members and really focusing on kind of setting a foundation for the next season. But we are starting to look at some new outreach opportunities. In fact, this week we are holding our preliminary outreach meeting. So we will be having some great ideas flowing from that, and we're looking forward to adapting to an online setting.
Participating in events like this in a virtual setting, because we have to be socially distanced. We considered a virtual summer camp, the kind of pros and cons of it. My knowledge, we also 3D printed parts for face masks that people at local hospitals could use. So just a myriad of different ideas that we're pursuing, trying to help the community at large and trying to help the FRC community.
Cool. And then how do you finalize your award submissions? What kind of editing is done on the written proportions of the submission?
So when we're finalizing our award submissions, we usually go, mostly it's students that work through the draft, and we'll have our coaches and mentors periodically look through it. And then when it comes towards the submission date, we usually have a week or 2 weeks that we look at it with the coaches together and really go through, is the message getting across? Are we really saying what we want to say? And throughout this, we have grammatical checking constantly and making sure everything comes across clear and concise.
I think, of course, we want to focus on checking like grammatical errors, syntax, things like that. I also think we really try to focus on trying to have a unified and clear message throughout the whole chairman's presentation. So from the essay to the video to the actual presentation to supplementals, I think maybe like there's a few core people working on each aspect, but then in the end, before we submit, we make sure that we're providing a unified message across the board.
For finalizing our award submission, we don't really do kind of like a big final edit. We have a kind of rigorous process for writing the essay. We go through sometimes up to 6 or 7 drafts. So we've done a lot of our editing and working the kinks out with our message beforehand. And then it's just looking at final phrasing. Is our message coming through? What is our voice? Kind of just the final touches, kind of putting the frosting on the cake, because you want to have your cake built before you're trying to do your final edits. That's a good tip. But yeah, that's what we do for kind of finalizing our award submission. We look over everything because it's all written by, I'd like to say like a week, 3 or 4 days. It's all written and done. We're just looking at phrasing and kind of the final touches. And that's the kind of editing that we do on the written portions of the submissions, just looking at phrasing, message, voice, and then of course, kind of grammatical concepts.
How do you prepare for the presentation? Is there any tips or suggestions?
I guess we could go first. So when it comes to the presentation, we really focus on trying to, I guess, explain deeper in detail what we went over in our essay and really highlight certain parts that we want the judges to really understand. And when it comes to our presenters, we normally have 3 of them, and we make sure that they practice over and over and over to make sure they have the presentation drilled into their head. And then we also run, like, I guess, mock presentations in front of the other students and leaders as well as the mentors, and we just make sure that they have tons of practice answering different questions and making sure they have a wider variety of questions that they answer so that they're ready for like any curveball that comes at them.
Yeah, for our team is pretty similar to what Madeline mentioned there. We have a pretty extensive question bank that we use that kind of is a conglomerate of all of the questions we've ever been asked, plus some other sample questions. I think there's probably somewhere over like 60 or 70 questions that we practice and make sure that everyone on our presentation team has an answer for all of them, or at least an idea of an answer. So I think that's probably the most crucial part of our presentation practice that we do, is just making sure that those questions are drilled into everybody's head.
One of the things, oh, go ahead.
Go ahead, Mr. Badsey.
I was just going to mention one of the things that we do is we practice handoffs, because the presenters won't necessarily be a technical expert in a particular area, but another presenter might. So we basically deal with how to handle a question and hand it off. They'll be able to answer it to the best of their knowledge and then hand it to someone that has a lot more knowledge on the same team.
Yeah, that's one of the things that we practice, because not everyone there is going to have had the exact same experience on the team. Some are going to have personal experiences with certain outreach events that the judge might ask a question on, and it's typically more impactful to kind of tell a judge about a personal experience and how it kind of first has impacted you, because it creates a personal connection. So practicing those handoffs is one of the main things we do, as well as just practicing the script a lot. That way, when you walk in, you're nervous, you're like, how's this gonna go? But then once you start talking, that's it. You just keep going. Everyone knows their lines, and it goes without incident. And then, as everyone else on here said, we have a bank of questions that we've been asked. We'll present to multiple people on the team, the entire team, the business mentors, all to kind of get a fresh set of eyes and ears on the presentation. So they'll ask questions that other people wouldn't, and it gives us a fresh perspective, and it always keeps us getting better.
And we have a question from the chat. How would one get their hands on that question bank, or maybe something similar?
I can take this question. So most of the questions that we usually test ourselves on when practicing presentations are usually taken from all the questions we've ever been asked, as Mr. Bonanno has also mentioned.
And then, in case this is your first time presenting chairmans, you won't have had a list of questions that you've been asked before. So just when you have people listen to your presentation, there are going to be things that come up. Like if you went over something kind of too shallow, but it's say like one of your biggest outreach events and you want to emphasize it, they'll ask a question. Or if there was a part that was a little bit confusing, they'll ask a question. So a lot of the questions that the judges ask sometimes aren't premeditated, but they're things that they kind of have a base question to ask and then hear an interesting part of your presentation and then kind of adapt it to that. So just having your mentors, having students listen to your presentation really is where you can get a lot of your questions.
I guess for us, when we practice in front of our other team members and mentors, we always tell them, pretend you know nothing about our team, so that they basically start off on a blank slate. And we also like to practice in front of people who actually may not know anything about our team. So they're kind of like, I guess, trying to ask questions that we may not have highlighted enough, or things like that from our essay and interview.
And what's the hardest question you've been asked?
I can't remember, honestly.
I don't know either.
We run
There's
through
so
a
many.
lot of them, but I don't think there's anything that
Sometimes judges
of
would ask like
ever stumps you.
specific questions that are like about a very specific detail that's kind of hard to answer sometimes.
That's where the handoffs come in.
Yeah, exactly.
If you don't know
Oh.
the answer, you can turn to one of your team members because they may remember the detail about that particular event. But every time we've gone through it, they've come up with some off-the-wall thing we never considered. So it's just random.
Yep.
Yep. Our team, it's kind of become notorious within our team. We were asked, not last year, but the year before, about whether our team pay it for or gives back. And it was a line that was from our essay that no one on the presentation team remembered was in the essay, and they chose wrong answering the question. And so it's really important. I guess the lesson from that is that it's really important for the presenters to know what exactly is in the essay down to the specific phrasing, so you make sure you're not screwing up with that.
How can a young team start another FRC teams?
I guess we could go first. So I don't think it really matters how old or young your team is, as long as you have the drive and you're willing to put in the effort to help another school or another organization start the team. I think that's what's most important, and really kind of helping them create a basis of how to start their team.
I also just wanted to add real quick that when you're starting a team, it's also about helping that team continue to grow and keeping that relationship. It's not just starting a team and then going to start more teams. It's about building it so they can work well and then be in this first community.
Yeah, I think if you can, like if you have some facilities or like maybe machining that you have and are able to offer potentially to other people outside your team, I think that's a nice place to start. And we do a lot of that with like community-based teams around our area. So I think starting with like small things like that, or even if it's just helping them with like just a certain aspect of something, I think starting off with small things can help.
In my experience, starting an FRC team, it always comes back to the students. There's a core group of students where this is like something they want to do. They want to spend hours on hours working together to build something. So you kind of just have to nurture those students. You have to, provide them with facilities, offer them guidance, kind of show them the ropes, because those core students are always going to have that drive, and they're going to kind of start the team themselves. You just have to kind of get them started. I know that sounds redundant, but I think it makes sense.
Something important that I think it was Jenna mentioned is that you don't have to be a team that's been around for 20 years in order to mentor. All you need is 1 year, because you've been through it once and the other teams have never been through it. So then you can guide them and show them all your mistakes and learn together.
What are some easy ways for young FRC teams to immediately help and impact the community?
I think one of the, more substantial things that younger teams can really do is help, kind of target the schools around in their area and help them start their own robotics programs. Something that we did a couple years ago was really focus on the middle school and elementary schools in our area. And in the end, it actually ended up benefiting our team, because the teams that we started and created there, those students went on and ended up joining our FRC team once they got into high school. So it's both kind of a method to help your community, but also help sustain your own team.
I think also outside of robotics, when you go to libraries or other conferences that other schools or organizations might hold in your community, I think going to those and spreading like, hey, this is what robotics is, I think it makes it really cool and really helps the community know more about robotics and how students can grow from there.
Similar to what Madeline mentioned, I think especially with a school like Parker, where we're based out of, it's K through 12 or pre-K through 12, where you have a younger community to kind of reach out to. It's really easy for a young team with not a lot of experience to start some of the first other programs, be it FLL or mostly FLL and even FTC within their own schools if possible. It's a really good way to kind of spread that message if you don't have a lot of either manpower or experience in terms of outreach.
One of the things I want to mention is that there are always STEM expos, and like Jen was mentioning, there are community events that are done at community colleges and schools and things. Those are a great place to get exposure. A lot of times, many people have never even seen the FRC Team before, and they're appropriately amazed when they see what you guys can do.
And it's through those events that you attend that you could also spark awareness for expanding STEM within a community.
And we have another question from the chat. How long is the essay?
10,000 characters in Times New Roman 12-point font, roughly 5 pages.
Nice one.
I think we were like 6 characters away from the limit this last year, so we always get super close.
Which part of the submission, interview, essays, or videos do you think is the most influential on the selection process?
So for us, it's always been the essay is the most important, and then we use the interview to kind of reinforce and highlight certain parts that we want the judges to remember. And especially with this last year, with a lot of the regionals being canceled, the essay tended being the only thing that teams were judged off of. So it was really the most essential part.
And as a presenter, I feel that the presentation is probably one of the most influential parts of the submission, because your essay could state all of your info that you're going to be presenting, but the presentation helps tie it all in together with your theme and can help get the judges to have a better understanding of the material.
Yeah, the interview and the essays are for sure, in my opinion, the most important. I've only heard of the video being used as like a tiebreaker as far as it influencing kind of the chairman's award and who it goes to. But the essay, for sure, because that's kind of what you get to spend all of your time kind of crafting, and that's the story that you get to hand in. But with your presentation, it gives you that face-to-face option where you're able to make that personal connection and kind of transmit and tell your story face-to-face. And that can also be a powerful medium of talking about who you are and what you've done.
And we have another question from the chat. How would you suggest the business department helps prepare students for college?
I think the business part really helps with connecting with other people, with public speaking, and then spreading a message that you want others to hear. And I also think like reaching out to others, because our business and our outreach team are intermixed together, where we're trying to make sure the community and like outside of our community as well is connected, and knowing like how much of FIRST and robotics can provide for people.
I think, like Jenna said, like the human interaction, public speaking, that is really important. And I think that's a skill you can really develop when you join business. I also think marketing, so maybe that's a website or, branding with all your logos and your team merchandise, things like that. And I think also just learning how to communicate like within your team. So making sure that everyone, like whether everyone is on the same page with everything, like even if like it's not just the business people doing outreach, making sure that you're including the entire team and that they all know about that. I think you develop those skills a lot.
I think as to how it prepares you for college, it really depends on how much you put into it and how you take it. We had a student a couple of years back who made our videos, and now he's like the vice president of media for a 3D printing firm in our local area, and he went to Cal State Long Beach and then transferred into the Chapman Film Program for TV writing. So you can go in the marketing direction of business, or you can use it to build public speaking skills, communication skills through your writing and your human interaction, and kind of build the confidence through exposure, where you can go talk to businesses, make connections, and utilize it that way. It's really whichever direction you want to take it, but you'll get back as much as you put in.
And then one more thing, I think one of the biggest things that you could learn from, especially the business aspect of the team, is the 21st century skills, which is, I guess, is a set of skills that really helps people this now day and age, with, I guess, all the new businesses and stuff like that, and working with as a team. But definitely check those out.
Yeah, I want to point out that each first team is actually like its own tiny company. So the business team actually gets a lot of practice in doing things that are done in industry, like making schedules, working with engineering and finance and everything else, learning how to keep to a budget, all those things which are, by the way, personal skills you should have for yourself, but they're also very helpful in college if you want to go into business, because those things are invaluable. You actually have a resume by the time you show up at school.
And what's your guys' team's general timeline for chairmans?
So on Team 3309, our chairman's submission begins to be drafted around Christmas season, and we aim to get it done a little bit into the build season. This is so that way we have plenty of time for members to draft and complete our essay, presentation, video, and handout material. This also allows members of both the robotics and the chairman's sub-team to participate more in the build season.
For us, our timeline basically begins in October and November when we start drafting the earliest drafts of our essays along with our supplemental, I guess we call them supplementals, I guess they're executive summaries. And then that continues following winter break, starting with drafting and with the essay again in January. And then as we move into later January, we really start ramping up script writing and presentation about then. And then once we get into February, most of February and the first week or so of March is just presentation practice all the time for the presenters. So that's our general timeline, I think.
I think when it comes to just chairman, it's not just the essay and presentation and award submissions. For chairman itself, it's basically all year round for us when we're working on chairman stuff, documentation, all that type of stuff. But when it comes to the essay and presentation itself, we try to finish it towards normally like right before build season, so that during build season it's just refining and editing and like perfecting it.
And we have another question from the chat. As seniors graduate, how does each of your teams work to pass down information as effectively as possible?
Recently, our team adapted a deputy position type of role where for each of the leaders, you have a deputy or someone that's of a younger age. Lower classman, there you go. The lower classman that usually takes on from that leadership position. And we also just have groups of people, usually one or two people that are surrounded by people who are in the business team that are seniors or juniors that are really working, and they also just sit there with us and work with us so that they have experience and that they are more comfortable as they go through the next year.
Our team is one of our core values and something that we pride ourselves a lot on, talked a lot about in our presentation this year, is Champions of Legacy. So it's basically a practice where we focus on passing down kind of like the question asked information. And so we don't have something necessarily as official as what Jenna was talking about, but we kind of have, I guess, like an unspoken kind of passing down of information. Like the department heads or leaders or whatnot will kind of take someone under their arm and make sure that they are involved in a little bit into all aspects of whatever leadership role, so they have a good plan and picture of what they're going to be doing the following season.
I think on 3309, we try to get the leaders to identify their replacements in the future years. So they usually have their eye open for, like Jenna was saying, the underclassmen. Try to find people interested in it and basically groom them up until the leadership positions.
Yeah, it's less kind of having a strict training program and more passing the torch in a sense. We kind of see someone who has the same drive, the same values that we do, and kind of wanting to do what we do. And that's on all facets of the team, whether it's, sticking around till 10, 11, 12 at night to work on the robot during build season, or whether it's staying up till those same hours working on the chairman's presentation or writing the essay. We kind of look around and see who's interested in what we're doing and who really enjoys doing it. And that's kind of how you get picked and how you pick someone, just on Team 3309.
I just want
And
to
oh, sorry, you can go.
I think the biggest thing is, even though we do have a business sub team, we make sure the entire team is involved with everything we're doing chairman's wise. I think that's super important to make sure everyone's aware. And I guess one of the mottos for our team is transparency, making sure everyone knows what's going on, no matter what sub team it is or no matter what it is.
And we just have a few more questions. What do you think is most unique about your team's chairman's process / presentation?
I think it's probably that we're kind of story-based. We take our theme and then we figure out how to craft the narrative around it. Because if you go to the First Inspires website, you can see all of the past chairman's essays, executive questions written by all of the teams that have won chairman's. And you can look at everything that they do. And something that we try and do every year is create a narrative around a theme in our outreach that we all agree with and think embodies the team values. Because if you can find something that's important to you and touches you, you can kind of take that and inspire others with it. And that's kind of what we look to do with our essay and with our presentation.
You forgot to mention the chairman's suicides.
Yeah, so if you've ever played sports, you know that suicides is something where you run to the first line, run back, run to the second line, run back, run to the third line, run back. And it kind of goes on like that. We do the same sort of thing with our chairman's presentation. We go until someone stumbles, and then we go all the way back to the beginning. Then we go until someone stumbles, and we go all the way back to the beginning. And it's as repetitious and tiring as it sounds, but it really drills it in. And it's something that I don't think any other team does.
I think what's unique about ours, and I think what we try to stick to every year, is we always stick to a theme. We go all out with the theme that we choose, and then we also try to do like a 3-tiered presentation. So generally speaking, that's like past, present, and future. This past year, that was creating and sustaining and expanding our legacy, and then grouping our outreach events and programs around that, and then ultimately creating our entire presentation around that. So I think that's the unique part about our chairman's process.
For our team, we have a vision, mission, and we have goals that we determine every new chapter, which is every 5 years for Team Spider. And we really emphasize for each team to also have these vision, mission, and goals that they want to build upon and they want to grow for their team. And I think that's how we organize our essay and our presentation, to emphasize these parts and to organize it so they're clearly stated out for the judges and for when people are listening to the presentation.
And we just have one last question, unless something else pops up in the chat. What's your best piece of advice for presenters or your team?
I guess for presenters or just in general for the team, make sure you know everything about your team and make sure you have a good understanding about basically everything. I mean, even if you're on the robot sub team, it's probably a good idea to understand Shermans or safety or imagery. So just make sure you know everything about your team and have a good understanding of what's going on.
I think what's also important is just to have fun and that really to show your passion, because really what the judges are going to see is when you're talking about it, if they see the light in your eyes, they're really going to see that and then differentiate your team from other people.
Yeah, I was going to say one of the things that really makes a difference is setting up a schedule. Like a lot of the teams have been talking about, planning ahead, keeping to it, adjusting to it as time goes by, making sure that all the activities are working in tandem and make sure that everyone is aware of it. You meet regularly so you can go over it and adjust as things go along. Keeps the team together, keeps that spirit, and also make sure things are coordinated. So if there's any problems, you can react to them quickly. So having that kind of schedule laid out, and a lot of the mentors know how to do a Gantt chart. They know how to do a linear schedule, that kind of stuff. So they can usually help you in setting something up because those are tools they use in business all the time. And that's a very good skill to have.
And an advice I have for when you're in the interview room is don't worry if you mess up a word, because none of the judges will really know if you got anything wrong or not. I feel that's one of the biggest hiccups of most presenters, especially what I've gone through.
My biggest tip for presenters is make sure that you have personal experience with things that you're talking about. So if you're talking about an outreach event or a program, try to have taken part in that actual event personally at some point in your past, because it seems a lot. They may not know whether it's authentic or not, but it always comes across as a little bit more authentic when you can give the judges kind of like a personal touch or tell a personal story about something you experience as opposed to talking about it in the abstract.
Yeah, I can't really emphasize that personal experience enough. I think it's for chairmans or really anything on FRC. It's just that you get out what you put in. So like I think just deciding for yourself and as a team what your end goals are, what you're willing to put in, what steps you're going to take to get to that, and then setting a schedule and then having a very clear progression throughout the season, I think is really important.
Yeah, definitely just take any opportunity that comes your way.
Yeah, my biggest tip for presenters would probably be have fun with it for sure. I mean, you spent weeks on weeks practicing your presentation. You might as well enjoy the time that you're in there. Be able to think on the spot, because say you have personal experience, say you know everything. There are times that a judge will just pick you out, just you, and then ask you a question. And if you don't know it, you need to be able to think on your feet. You can't go through all of the questions you practice, all of the script, the chairman's essay. Like say you memorized it all. You can't look back for like any like piece of minutia. You kind of just have to answer the judge and just involve your mission, involve your drive, and involve any outreach that's relevant, because they'll see like you not being robotic. Think about it. If there are all of these presentations that go through the entire day that all of us have memorized, that's a lot of 7-minute sequences of just us kind of like preaching for a sense, because we're kind of talking to them, but not really involving them. You get to talk to the judges in the questions. So really make it stand out.
And it looks like we have our last question from the chat. How well do other departments work with the business department?
Could you restate the question, please?
Yeah. How well do other departments work with your business department? So like other parts of the team.
I think teams do have trouble like when it comes to separating robot work with more of the chairmans. But I would say that they work pretty well together because we have a documentation lead and then we have all parts working together, as in we have every member know, like Madeline said earlier, that everyone knows what's going on for each sub team. We have updates at the end of each meeting. We have trainings that we're coming up with, and then we also have outreach that everyone does outreach. Everyone goes to these events, everyone experiences it. And I think when you have them all coming together and when you're writing the essay, having all those perspectives is really important.
I think that all teams, all sub teams, even if they don't work well with business, at least respect it, because we get to make sure that they get to do all of the fun things. If you want to build a robot, if you don't have money, you can't build a robot. If you want to go to multiple regionals, if you don't have the funding, you can't go to regionals. I think the most fun part about being in robotics is going to outreach events and being able to talk to little kids who have maybe never seen something like that, and then getting to see, as Jenna said earlier, the light in their eyes when they see something fun and something that they want to do. I think it's the most rewarding part. And if that's what I get to do and that's what I get to involve my team in, there's no way that they can be mad. So I think business gets well along with everyone on the team because we get to have the most fun.
I'd just like to reiterate what Adrian said there at the beginning about having other departments, I guess, respect business. I can say, like, to be honest, it's like we've had troubles in the past kind of dealing with team cohesion, especially with other departments working with business. But I can say recently, I can say that this past season specifically, we kind of made it through, I don't want to say drama free, but we made it through being able to bring everyone together. And I honestly, I think a big contributor of that is the leaders of our team are friends most of the time outside of robotics. And that really does help bring departments together and kind of respect and work with one another.
And it looks like we're going to wrap up this workshop. So thank you, panelists, for today's workshop. Let's thank Firebots 3309, Spider 1622, and Warlords 2485. Tomorrow is the last day of the summer series where Team Spider, Warlords, and Firebots will host a workshop on recruitment and growing a team at 5 p.m. After that, we'll be creating a curriculum with Robot Dolphins from Outer Space at 5:45 p.m. We highly recommend you to tune in. Otherwise, please check out our Instagram at Robot Dolphins for more information about the summer series. This has been Morgan Malloy from Team 5199. Thank you, our panelists, and thank you for tuning in.
Thank you, everyone.
Woohoo!